We can imagine, as it were, turning the knobs, which were set up at the time of the Big Bang to determine how it expanded and what it was made of. And if we turn the knobs very slightly, we find that we would end up with a universe that would not be so propitious for the emergence of life.
Take gravity, perhaps the most familiar of the laws of nature. Its value determines how much things are attracted to each other. From us being stuck to the Earth circling our sun, to the stars held in place in remote galaxies billions of light years away. Just the tiniest adjustment to the value of gravity in a computer simulation of the Big Bang, and our universe doesn't emerge at all.
For example, if gravity were very strong, then anything as big as us would get crushed. If there were no gravity at all, then no stars would be able to form because they're held together by gravity. No planets either.
And the other laws are equally fine-tuned. Any slight adjustment to their value, and we would never exist. There is no known reason why these values should be set as they are, yet they do seem to be fine-tuned to allow our creation.
To some of us, not all, to some of us, it looks like we have to live with the idea that the constants of nature, the laws of nature, everything that we know about, somehow was influenced by our own existence. This is something which physicists hate the idea of. Most physicists want the world to be controlled by pure mathematics, not by our own existence.
Perhaps there is a rational explanation for why the laws of nature were set so precisely at the birth of our universe. Until we fully understand those first moments, we should not assume any special reason for their values.
When we trace cosmic history back towards the so-called Big Bang, as we get closer to the very beginning, we become more and more uncertain. That's because conditions then become more extreme. We lose our foothold in experiment because conditions are more extreme than we can simulate or achieve in any experiment on Earth. So there are great uncertainties.
For a while, mainstream cosmologists were content that once we understood better the underlying reason for the laws being set as they are, fine-tuning would no longer seem so mystical and would once again fall within the realms of physics and mathematics.
The general view of this, for most physicists, is that these fine-tunings are largely accidental, that the constants of nature are determined by some mathematical principles which have nothing whatever to do with our existence. Impersonal, mathematical, and we were just incredibly lucky that that mathematics happened to give rise to a universe with all this kind of fine-tuning, just precisely so.
Our universe seems to be defined by a set of numbers which in some sense look special. If we had different numbers, we would end up with a sterile universe. People react to this seeming coincidence in a number of ways. You could say it's the outcome of some kind of design or providence. We could say it's a brute fact we have to accept, because these numbers might be determined by some theory which we haven't yet discovered.
For a while, it was possible to believe that the laws of nature were not so precisely set as to require the hand of a creator. But then a completely new fundamental property of the universe was discovered. An anti-gravity force present in space itself. It is called the cosmological constant, And when cosmologists calculated its effect on the evolution of the universe, they realized it had to be very finely tuned indeed.
The fine-tunings, how fine-tuned are they? Most of them are 1% sort of things. In other words, if a thing is 1% different, everything gets bad. And the physicist could say, maybe those are just luck. On the other hand, this cosmological constant is tuned to 1 part and 10 to the 120 decimal places. Nobody thinks that's accidental. That is not a reasonable idea, that something is tuned to 120 decimal places just by accident. That's the most extreme example of fine-tuning.
No force in the history of cosmology has ever been discovered to be that finely tuned. The cosmological constant needs to be set to 1 part in a trillion, 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 trillion. Otherwise the universe would be so drastically different that it would be impossible for us to evolve. That the cosmological constant arrived at such a tiny value by chance seemed to be out of the question, but the alternative explanation was also impossible to contemplate.
Physicists did not want to accept the idea that the laws of nature might be controlled by the benevolence of nature. There should be no reason why the luck should just have it that we can exist. It's too much, it's a stretch. It's much too far to stretch.
It seemed that hidden in the laws of nature was a value so precise that it was impossible to deny that our universe was designed. But a designed universe requires the existence of a designer, a notion that even the anthropic scientists did not want to entertain.
In the last 30 or 40 years, more and more has been discovered by physicists and cosmologists that give evidence of a universe that's very finely tuned. That is, certain of its basic properties, the fundamental constants that govern what the universe is like, have to be within very, very finely defined limits in order to have a universe like we have on which carbon-based life is possible. And we call that the fine-tuning of the universe. For example, the ratio of the electromagnetic force to gravity in the early universe has to be accurate to about 1 part in 10 to the 40 in order that we can have the chemistry of the universe as we now see it. Now, 1 part in 10 to the 40, to get some idea of that, let's imagine that we covered, say, the whole of Russia with small coins, and we built the piles of coins over the whole of Russia to the height of the moon. And then we took 1 billion systems like that, and we painted one of the coins red, and we asked you to blindfold a friend and go and find it. They'd have got about 1 chance in 10 to the 40 of finding it. So it's a very small probability.